Hi everyone, this is lesson 10.4, quadratic applications. So we did 10.3, which was also applications, so we're going to continue with this concept today. Okay, so this problem says an arrow is shot over a lake from a cliff that is 20 feet above the lake. So this is where the arrow is being shot from. The arrow returns to the same height, which will be this point here. Okay, from where as the cliff at a distance of 160 feet. So then what that means is that the value of x at this point is 160. And notice that when the arrow gets shot, that means it has not traveled any distance. So the distance is 0, but then it's being shot from 20 feet above the lake. So this is the lake, so that means the y value is 20. And then from this point, it reaches that same height after 160 feet. And the question is, what is the y value here? Well, if it's 20 on this point, then it's going to be 20 also here. That's the height, 20 feet. Okay. And let's see what else. Its path traces a parabola and reaches a height of 60 feet. So that means the y value here is 60, about 6 feet above the lake. So the question is, what is the x value? Well, to get the x value, you just take 160. Okay, take 160 feet and divide that by 2, and that'll give you, in this case, that will be what? What is that equal to? And yes, you are correct. If you thought 80, that's the answer to this one. Okay, now we don't know what is the x value when the arrow hits the lake. So then we know the x value, the y value is 0, but the x value we don't know. Okay. So then part A, this is part A. Part B, describe a reasonable domain and range in interval notation. So notice, domain, we go from 0, right, from 0 feet, and then it goes all the way to 160. So let's go a little bit over 160, so that let's make it 200 feet. So again, notice this is not an infinite domain or range, because we have a starting point and an ending point, which will be here. So we just went a little bit over. I think this will be less than 200, but I'm just guesstimating with 200. If it's more than 200, then we can always come back and fix this, or change the domain, this 200 value. The range goes from, this is 0, so the minimum for y is 0, and the maximum, this is 60, so I'm going to say 70, just go a little bit above the maximum point, okay? And then this is asking us to write an equation that relates the height of the arrow above the lake to its horizontal distance from the cliff. So to that end, let's write the x, let's choose a point on the graph and also the vertex point. And the vertex point is, these are the coordinates of the vertex point. I'm going to choose this point here. So I'm going to label h and k, okay, following this formula, and also x and y. So I'm going to go to this equation and substitute for each one of these letters. So then y is 20 equals, this is the unknown, a, x is 0, minus h is 80, square, and then plus k is 60. And then I'm going to simplify this. So then we have this so far, 0 minus 8 is negative 80. So then I'm going to simplify this further. And we have that negative 80 squared is 6,400, right? So then I'm going to subtract the 60 from this side and from this side. So we have 20 minus 6 is negative 40. Then I'm going to divide by 6,400 on both sides of the equation. And when I divide negative 40 by 6,400, that gives me negative 1 over 160, which means the equation is y equals negative 1 over 160, x minus h is 80, square, plus k is 60. So this is the equation for this problem. Okay. All right. Part D says, what is the arrow's height above the water when it has traveled a horizontal distance of 100 feet? Which means when x equals 100, what is the y value? Okay. So what is y equal to? So once we have the equation, all we have to do is we can either graph this. So I'm going to go to y equals and clear whatever I have there and enter the new function. So the new function is negative 1 over 160, open parentheses, x minus 80, close the parentheses, take the square, and then add 60 to it. Before I graph it, I'm going to go to window, and notice my x minimum, it's going to be 0 for the domain, and my maximum, I'm going to change that to 200. Okay, scale of 1, then minimum is y equals 0, and then we have 70 here, so I'm going to change this one to 70. And then I'm going to graph the function to see if I can see the same graph as I have on the diagram here. So I'm going to graph it. As you can see, it's similar to it. Okay, so then what I'm going to do next is I'm going to press second trace, and then I'm trying to find a value. Okay, so I'm going to press 1 is 1, so just press enter. And I want when the arrow has traveled 100 feet. So I'm going to enter 100 for x, and then press enter, and the calculator says that it's 115.2. So then for this one here, y is equal to 115 divided by 2, which is actually equal to 57.5 feet. And that's the answer to this problem. Okay, let's go to part E. At what distance from the cliff will the arrow strike the lake? So this is why we made it to include, okay, this point. We don't know what x is equal to. We know y is 0. So then what I'm going to do is I can use a calculator for this. Okay, so what this is asking is when the distance, so for this one, when the distance, what distance? So we know y is going to be equal to 0. The question is, what is x equal to? Okay, so then I'm going to go to the graph again, and I see that when y is equal to 0, I can use, again, second trace. I want the 0, so I'm going to press 2, and then it says left bound, so before the graph crosses the x-axis, and I should have left some negative values here, but I hope we can do this. Okay, so let's say above the x-axis, then get below it. That should be below enough. And it says that x is 177.9795. So I'm going to round this to 177.98 feet, which is approximately 178 feet. Okay, so that's the answer to part E. The next part, which is part F. As it travels, how many times will the arrow reach a height of 40 feet? Calculate the horizontal distance where this occurs. So I don't know. Let's say this is 20. So let's say it's, I don't know, about right there. There's 1 point. Okay, that's where the height will be 40 feet approximately, and it's going to be here again at 40 feet. So what I'm looking for is when y is 40. So again, I'm going to press second trace, and then I want the value, right? So in this case, we could use a value. So let me see. Let's try this one. Let's see, height of 40. So for this one here, I just thought of something. Let me just draw a diagram so you can kind of visualize this a little bit better. Okay, so we know the graph looks like this, right? The graph goes like this, strikes the lake, and then so we know this will be 1 point, and this will be another point, and the y value at this point is 40. So this means y equals 40. So then what I'm going to do is I'm going to go back to y equals, and then enter another function, and that is y equals 40. I'm going to enter this one here. Okay, so 40, then I'm going to graph them, and there you see that line. Okay, so then I'm going to find the intersection by pressing second trace, and then I want the intersection, so 5, and then I'm going to get before the graph, the parabola crosses the line, the red line at this point, so get below the intersection, then get above the intersection, and press enter, and it says, so for this one, this is, I was doing this wrong. So first curve, second curve, press enter, and it gives me, for that one, 23.431. So then one intersection happens at x equals 23.43 feet, and the other intersection, so that's this one here. Okay, so that's that intersection, and let's get this one now. So for this one, let's do second trace 5 again, and let's get to the other intersection on the graph. Okay, so I'm getting close enough there. So we're on this, on the parabola, then the line, press enter again, and guess, yes, it says 136.568. So then this is 136.56, and then has an 8 next to it, so 57 feet. So this is the answer to that problem. I hope this is not too difficult to understand. Thank you for watching. I'll see you in the classroom. Bye-bye.